Algebra 2, Lesson 92, Boat in the River Problems. Now, these are actually pretty fun problems. They're just a variation of the distance equals rate times time problem. In this case, the rate varies depending on if your boat is going downstream or upstream. For those of you who don't know and are not familiar with the river, downstream means that you're going with the flow of the water, which means the water helps you move faster. Upstream means you're going against the flow of the water, which means the water will slow down your rate. So, we're still going to be using the basic. Whoa, how did the camera get all sideways? All right, we're still going to be using the base equation of distance equals rate times time. The only difference here is our rate will be substituted for either boat plus water or boat minus water. And your book, I don't know why they don't tell you this, but your book will also use this equation for planes and wind. So this also works for planes and wind. If a plane is going against the wind, then it would be plane plus wind. If the plane's going, if the plane's going against the wind, it would be plane minus wind. If it's going with the wind, it'd be plane plus wind. So let's go ahead and look at an example problem and see how we can solve this. Let's see here. We'll do this example. They tell us that Robert and Clay could go 60 miles downstream in the same time it took them to go 20 miles upstream. So we have two distances, 60 and 20 miles. So I've got 60 miles downstream, 20 miles upstream. So these are my two distances. Now when it comes to my rate for downstream, I'm going to have boat plus water. Now for rate upstream, I'm going to have boat minus water. And then they'll both be, now let's see here, they said it took the same amount of time, so the times are going to be equal. So sub-equation there would be T1 is equal to T2, or when your times are equal, you don't need to subscript your times because they're both the same. Now, if the speed of their boat was 8 miles per hour in still water, what was the speed of the current and what were their times? So they give us one substitution, which is that boat is equal to 8. So I can go ahead and hold on. Nope, it's gone. All right, we can substitute 8 for the boat. So that changes these equations. I now have 60 equals 8 plus water times T, and 20 equals 8 minus water times T. So the goal here is so the interesting thing about boat in the river problems is we can get a double unknown, or kind of like a double substitution, and then we can also eliminate at the same time. So if I simplify this equation, you'll see what I'm talking about. So if I rewrite these using distributive property, you'll see what I mean. So over here we have 60 equals 8t plus t sub w. And here we have 20 equals 8t minus t sub w. And this is the elimination point I was just trying to explain to you. I should have just showed you. But we see here in these two equations, we both have time and water, and they have opposite symbols. So what I can do is I can add these equations to eliminate time and water. Once I do that, I now have one equation with one unknown, which is 16t equals 80. I divide each side by 16. See here, 80 divided by 10 is 8. 16 divided by, wait, hold on. What am I doing here? 80 divided by 8 is 10. 16 divided by 8 is 2. 10 over 2 is 5. So 5 is equal to t. So now that I've solved for t, or the time, I can then go back and solve for water. All I have to do is plug it into one of these equations. So I'll use the upstream equation. If I take 20 equals 8 minus w times 5, I can then solve for w. So I distribute again. I get 20 equals 40 minus 5w. If I subtract 40 from each side, I get negative 20 on this side equals negative 5w. Divide each side by negative 5. and negatives cancel, and 5 goes in 20 4 times. So 4 is equal to the water. So water equals 4, time is 5 hours. All right. Well, those are boat in the river problems. It's just, us using substitution and elimination. Again, once you have all your information written down, you have your rate and time equations written down, simplify them, and then look for a way to eliminate, or sometimes you'll have the time of the water. Look for a way to substitute. So we're just using these skills more and more in different types of problems and seeing different ways that they can be useful. So if you have any questions, let me know on Moodle, and I will see you in class.